In this video, we are going to complete some subtractions, and by doing so, we're going to complete our review of binary math. So we know computers can't subtract, so again, we take the 2's complement of the subtrahend and add it to the minuend. Again, just to make sure we're clear, the minuend is the top number, subtrahend is the bottom. We're going to take the 2's complement of that guy, and we're going to subtract, or we're going to add it back to, so yeah, I even slipped myself. We're going to add it back to complete the subtraction. That is how we subtract. All right, so let's do some subtraction. We're going to take 12 minus 8, and big spoiler alert, the answer there is 4. All right, so there's a 12, which is the 8 and the 4-bit that are set. Okay, we need some value to go here. We know we're not just going to put an 8 in there, so we need the 2's complement there. And that's hopefully going to give us the correct result. So we need the 2's complement of 8. While you're new at this, and again, this is something I preach over and over again, is do the 2's complement somewhere else. Don't try to do it. Don't try to muddle the issues with what you're doing in binary. So here we go. We're going to flip the bits and add 1. So that is an 8. So flipping the bits is rather trivial. And then we're going to add 1 to it, and this is going to give us a lot of carries. So let's keep going. 0 carry the 1, 0 carry the 1, that comes down. And then these are just going to come down. And that is the 2's complement of 8. Now, in order to copy this back, I'm going to remember this is 4 ones and 1,000. Okay? So I'm going to come back here. This was our original problem. And we're going to put in the 4 ones and 1,000, which is the 2's complement of 8. The way I do that is I just write TC8 over there, so I know it's 2's complement. That's just kind of my shorthand. And then we're going to add them together. So 0, 0, 0 and 0, that's a 1, that's a 0 with a carry. And remember, if you recall what we did in the last course when we learned this, when we do this, we are going to float a bit off the end of the register. And we know that, and that one is ignored, and what is left on the register is the result. Okay? So that's going to be 0 carry the 1, 0 carry the 1, 0 carry the 1, again one more time, and there's the carry off the end. And that is in fact 4. So we know this is happening, unlike when we don't have enough bits to do our math and it's unexpected and all of a sudden we get a bad error. In this case, we're doing subtraction. We intend to float one off the end, and what's left on the register is going to be the result we want. Okay, so 4 is correct. So adding the 2's complement gives us the result remaining on the register. We ignore the carry bit off the end of the register. It's expected and ignored. Okay, let's do another one. 25 minus 11 is 14. So there's a 25. We need the 2's complement of 11 to give us some sort of a result. So here's our 2 rules. Flip the bits and add 1. There is an 11. Okay? And that is what we get when we flip the bits. From an 11, we're going to add 1 to it, which is rather trivial because everything just kind of comes down. All right. So again, I'm going to remember this 4 ones and 01, 01. So we're going to come back over here. There's our 25. And we're going to put in the 4 ones and 01, 01. That's our 2's complement of 11. Now we're going to add. 1 and 1 is 0. Carry the 1. That comes down. That's a 1. That's a 1. There's a 0. Carry the 1. Looks like we're getting into the same pattern of floating 1 off the end. Sure enough. And we get a 14, right? What is this one? This is a 1, 2, 4, 8. So 8 and 4 is 12, 13, 14. Okay? So it works. We got it right. And we're good. And those are our 2 rules again. We know we're floating 1 off the end, and what's left on the register is the value that we're looking for. Okay. What we're going to talk about in the next video is the concept of abstraction. See you on the other side.